continue with the partners of Lawrence Tapaya and from Base A, Trinity. So today, we discuss about DC machines, specifically key points of construction of DC machines and principle of operation of DC generator. Principle of DC generator. So what is a DC generator? So a DC generator is an electromechanical energy conversion device that converts mechanical power into a DC electrical power through the process of electromagnetic induction. So a DC generator operates on principle of electromagnetic induction when the magnetic flux linking a conductor change. An EMF or electromotive force is induced in the conductor. The energy conversion in the generator is based on the principle of the production of dynamically induced EMF. A DC generator has a field winding and an armature winding. The EMF or electromotive force induced in the armature winding of a DC generator is alternating one and is converted into direct voltage using a commutator mounted on the shaft of the generator. The armature winding of DC generator is placed on the rotor, whereas the field winding is placed on the stator. Also, whenever a conductor casts magnetic flux, dynamically induced EMF or electromotive force is produced in it according to Faraday's law of electromagnetic inductions. So what is Faraday's law of electromagnetic inductions? So based on the short description of Faraday's law of electromagnetic induction, which is induced in the loop due by a changing magnetic flux is equal to the rate of change of the magnetic flux reading the loop. Also, this EMF or electromotive force causes a current to flow if the conductor is inside. So, as for now about construction of DC machines, my partner Lawrence Tapaya will explain.
Good day, I am Mark Lawrence Tapaya and I will continue the discussion of DC machines, which is I'm going to discuss the next part, which is the constructions of DC machines. So earlier Ate Lisa discussed what is the principles of DC generator and how it works. So it came from mechanical energy converted into electrical energy. So I'm going to discuss the machines, which is the converter of from mechanical energy into electrical energy, and I'm going to discuss the constructions of DC machines. So DC machines is consisted of 6 main parts, which is the following, which is the yoke, the magnetic field system, the armature core, the armature winding, the commutator, and brushes. Also, it has a 4 sub parts, which are the follows: the poles, the pole shoe, the stator, and the rotor. So this is the picture out of the constructions of DC machine. There's a field winding, which is the one hold the poles. The poles hold the field winding, the yoke, which is the outer layer, which is the cylindrical part, like that. The armature core, which is the one who rotates between the armature winding, the brushes, there's a brushes there, the commutator, which is the one who converts the alternating current into armature winding across the load. So I'm going to discuss it one by one. So let's start first with the yoke, which is the outer frame of DC generator. It is a hollow cylinder made up of cast steel or rolled steel. The yoke serves 2 purposes, which is to support the field, pole, core, and acts as protecting cover to the machine, and is to provide a cut for the magnetic flux produced by the field winding. The next one is the magnetic field system, which is the magnetic field system of a DC generator. Is a stationary part of a machine. It produces the main magnetic flux in the generator. It consists of a limited number of poles, cores bolted to the yoke and field winding wound around the full cord. The field system of DC generator has a filament poles, which is the poles inwards, and each pole has a pole shoe having curved surface. The pole shoe serves 2 purposes. It provides support to the field coil, and also it reduces the reluctance of the magnetic circuit by increasing the cross-sectional area of it. So the next one is the armature core, which is the armature core of this generator is mounted on the shaft and rotates between the field pole. It has a slot on its surface, and on armature conductors are put in these slots. The armature core is made up of soft iron lamination which are insulated from each other and tightly clamped together in small machines. The laminations are keyed directly to the shaft, whereas in large machines, they are mounted on a spider. The laminated armature core is used to reduce the eddy current loss. But always remember that armature core is the one who rotates from between the field poles. The next one is the armature winding. The armature winding is the insulated conductors are put into the slots of the armature core. The conductors are suitably connected. This connected arrangement of a conductor is known as an armature winding. These are two types of armature winding, which is the lap and the wave winding. The next one is the commutator. The commutator is a mechanical rectifier which converts the alternating EMF generated in the armature winding into the direct voltage across the load terminal. The commutator is made up of wedge-shaped copper segments isolated from each other and from the shaft by mica sheet. Each segment of commutator is connected to the end of armature coil. The next one is the brushes, which is brushes I mounted on the commutator and also used to collect current from the armature winding. The brushes are made of carbon and is supported by a metal box called brush holder. The pressure exerted by the brushes on the commutator is adjusted and maintained at constant value of mainspring. The current flows from the armature winding to the external circuit through the commutator is a carbon brushes. So the next let's talk about the sub part, which is start with poles. The function of our poles is to hold the field windings, like what I said earlier. These windings are wound on poles and are either connected in the series or parallel by the armature winding. Next one is the pole shoe, which is pole shoe is mainly utilized for spreading the magnetic flux to prevent the field coil from falling. Also, the stator is the main function of the stator is to provide magnetic field where the coil spin. So, ang stator daw ay yun na po yung nag-provide ng magnetic field where the coil spin. Also, a stator includes two magnets which located into the opposite polarities forcing each other. So these magnets are located to fit in the region of the rotor. The next one is the rotor. So rotor in this machine includes slotted iron lamination with slots that are stuck onto the shaped cylindrical armature core. The function of lamination is to decrease the loss caused due to the eddy current. So let's have a recap about what we discussed earlier. So the field winding is the one who the pole hold the field winding. The armature core is the one who rotates from between the field poles, or the poles ay the brushes is the one who collect the current from the armature winding. The yoke is the outer frame, which is made up of steel and rolled steel, and the commutator is the one who converts the alternating EMF into voltage across the load terminal. So the next one is our reference, and I think that's all. Thank you.